It is known as the Darcy formula for the loss of air in pipelines. Although the frictional resistance is only proportional to V square for turbulent flow, the formula can be applied to viscous flow, in which resistance is directly proportional to V, by making F inversely proportional to V. So there are other expressions of the Darcy formula, which one of them can be proven thus. So I'm going to walk around this. Let me box this up. So other expression for the Darcy formula can be gotten like this. When you have V is equal to Q over A, which now be equal to 4Q. Your area is 1 over 4 pi d square. Let me write it like that so as to aid understanding. Q over 1 over 4 pi d square. So this 4 comes up here and it actually becomes 4Q. So I will erase that 1 over 4 now. So it becomes that expression. And now inputting this into the Darcy formula, you have HF will now be equal to 4FL over D multiplied by V square over 2G, which will now be equal to 64 FLQ square. When you put the value of V as 4Q over pi d square, 64 FLQ square over 2G pi square d raised to the power 5, which can be simplified further. HF is equal to 32 FLQ square over G pi square d raised to the power 5. So this is it, and sometimes it is written as HF is equal to FLQ square over 3.03 d square, because 32 over G pi square is actually a constant, and you can find the answer for that expression to be 3.03, which is sometimes approximated as 3. So an alternative form of this equation is 4, okay, no more 4, is FLQ square over 3d square d raised to the power 5, sorry, d raised to the power 5 over 3d raised to the power 5. It is within 1% error, and this can easily be used to solve equations or questions involving discharge. So let's quickly take one example on that concept. Find the loss of air due to friction in a pipe 300 meters long. So we are given the length as 300 meters and 150 millimeter diameter. So D is equal to 150 millimeter diameter when the discharge is 2.73 meter cube per minute. So Q is equal to 2.73 meter cube per minute, and the resistance coefficient F is equal to 0.01. So now what is our formula for finding head loss? HL will be equal to FLQ square over, okay, don't let me use that formula, let me use the more expressive one, 32 FLQ square over G pi square d raised to the power 5. So we know everything except head loss, HL. So we can easily find that will now be equal to 32 times F, which is 0.01, times L is what? L is 300 meters, times q square. Q is 2.73 meters cubed per minute. And how do we convert that? Normally the unit is supposed to be meter cubed per second, but now we have meter cubed per minute. So to convert this minute to second, we have, this is 1 minute, it will now be 60 seconds. So that is basically meter cubed over 60 seconds. So we divide this expression by 60. So Q will now be equal to 2.73 over 60, which will give us 2.73 divided by 60, which will give us 0.0455 meter cube per second. So now we can use it, and that will now be equal to 0.0455 square over g. What is g? Acceleration due to gravity, 9.81 sorry, times pi square times d. Diameter is 150 millimeter, which will be divided by 1000 to get the value in meter, which is 0.15 raised to power 5. And the answer for this, when you calculate it, is 27.3 meters of water. Remember, the unit for head loss is either in meters or Newton meter per Newton, which is basically still meters. I hope it is clear. I'm Olunlade Joshua. Please feel free to check any of the other videos in this playlist, in this fluid mechanics playlist, to understand more the concept. I will be back in the next tutorial video, and I will say bye for now. Please like this video and subscribe to the channel. Let me know what you think in the comment section below. Goodbye.